Hey, network engineers and automation fans! Today we're going to walk through a quick Netlab demonstration showing how easy it is to spin up a multi-vendor network topology for testing and learning. We'll be creating a 3-router OSPF triangle topology using Arista CEO's containers. First, let's check what virtualization providers we have available. As you can see, we've got containerlab with Docker running and ready to go. The libvirt and VirtualBox providers show are not configured in this environment. Containerlab is perfect for our demo since it's lightweight and spins up fast. Quick status check shows we don't have any labs running yet. We're starting with a clean slate. Let's take a look at our topology file that we've prepared for this demo. Here's our simple but effective topology definition. We're using containerlab as our provider with 3 Arista routers, Router 1, Router 2, and Router 3. Notice we're specifying the image version. We've enabled OSPF module to get some dynamic routing going, and we defined connections, the links. The links section creates our triangle topology. Router 1 connects to Router 2, Router 3 connects to Router 1, and Router 2 connects to Router 3. This gives us a nice redundant setup where we can see OSPF doing its thing with multiple paths. Now for the magic, let's bring up our lab. Netlab is doing several things here automatically. First, it's creating all the configuration files. You can see it generating the containerlab, YAML, Ansible inventory, and device-specific configurations. Pretty neat how it handles all that boilerplate for us. Next, it verifies that containerlab is installed and working properly. It's always good to check your tools before using them. Now it's spinning up the containers. Watch as containerlab creates our 3 CEOS instances and connects them according to our topology. You'll see it creating the Docker network, spinning up containers, and establishing the inter-container links. The really cool part is watching the post-deploy actions. Netlab is automatically configuring each device with initial settings and then deploying our OSPF configuration. No manual configuration needed. It's using Ansible under the hood to push configurations to each device. Look at that. All 3 routers are up and configured. The whole process took just about a minute from topology file to running network. Perfect. Our lab is now running. You can see all 3 routers are up with their management IP addresses, and containerlab is handling everything smoothly. Each router has been running for some time now. The name is the actual Docker container name that containerlab created. The management IP is important, but we don't need to know it to connect to Netlab network node. You can use it to SSH to the node, but the Netlab connect command does the trick for us. Let's jump into Router 2 and see what's happening. Netlab makes SSH connections super easy. It handles all the IP addressing and authentication for us. We're now on an Arista CEOS device. Notice this is the engineering build we specified in our topology file. The system's been up for a few minutes, which matches our lab deployment time. Let's see the interfaces. Here's where it gets interesting. Look at our interface setup. Ethernet 1 and Ethernet 2 are our data plane interfaces connecting to the other routers, each with their point-to-point subnets. Loopback 0 has our router ID, and Management 0 is on the containerlab management network. Netlab calculated all these IP addresses automatically based on our topology. Standard routing instance setup. Our routing is happening in the default instance, while management traffic uses the dedicated management instance. Clean separation of concerns. This is the good stuff. OSPF is working perfectly. We can see routes to our neighboring routers' loopbacks. 10.0.0.1 for router 1, and 10.0.0.3 for router 3. Notice the interesting record pointing to 10.1.0.4 network. That's the link between router 1 and router 3. We're learning it via OSPF from both neighbors, which shows our triangle topology is working with full redundancy. The detailed view shows us the next hop information. You can see we have equal cost multipath routing available for that router 1 to router 3 link. We could reach it via either neighbor. That's OSPF doing exactly what it should in a triangle topology. And now, let's verify our management connectivity. Perfect. We can reach router 1's management interface with sub-millisecond latency. ContainerLab's networking is working flawlessly. Just a little fun before we wrap up with echo command. And we are exiting back to our Netlab host. Time to clean up. Netlab makes teardown just as easy as deployment. It's destroying all our containers, cleaning up the networking, and removing host entries. Everything back to a clean state. And we're back to no running labs, clean as a whistle. That's Netlab in action. In just a few minutes, we spun up a 3-router OSPF topology, verified connectivity and routing, and tore it all down. This is incredibly powerful for network testing, learning new protocols, or validating configurations before deploying to production. The beauty of Netlab is how it handles all the tedious setup work, IP addressing, initial configurations, and protocol setup, so you can focus on the actual network engineering work. Whether you're studying for certifications, testing new features, or prototyping network designs, Netlab gets you from idea to running network in minutes, not hours. Try it out with your own topologies. You'll be amazed how much faster your network lab work becomes. Thank you for watching, and have a great day.